Hello and welcome to part 2 of our polar coordinate unit. Last time for 8.1 anyway, we started learning about polar coordinates, and it's a new coordinate system that revolves around circles. A rectangular coordinate system revolves around squares, pretty much rectangles. So we learned that we could represent coordinates as polar coordinates because they're circular units and we have a radius and we have radians. Plotting polar coordinates looks like a normal coordinate but with those specific radius and radian values. We also have multiple representations of those polar coordinates, and now we are going to explore converting polar to rectangular and vice versa. I'm going to put this in pink so you do not have to copy this down, but it is interesting to note because what happens if you have, for instance, a coordinate 1, 2? You'd plot that here, but what would that look like in a polar coordinate system? Where would this land? Well, we for sure know it's in quadrant 1, so it should land somewhere in quadrant 1. Okay? Same thing happens if we have, like, let's say something in polar. If I have, let's say 3, 3 pi over 4, that would land on the third ring and in quadrant 2, if you were to label this. That would mean it lands in quadrant 2 here. Okay? So, that idea revolves around a couple new things. We're going to convert first to from polar to rectangular, which means we are given a polar coordinate. All right, so that's in pink. You don't have to copy that down. And we have a way to bridge this gap. Okay? X should represent, if you're thinking about trig functions, X represents which trig function? Cosine. So what our conversion for this is going to be X is equal to R for the radius times cosine, theta. Okay? Then we also have Y. Y represents sine. So we can take Y is equal to R times sine theta. And then from here, we could actually convert it back to a typical X, Y coordinate. That's why we have this X and Y. Whatever this value is equal to, that will be your X. Whatever this Y, sorry, I think I said X. Whatever this Y is equal to, that will be your Y value. Okay? So let's take a look. If we have a polar coordinate, 4, 2 pi over 3, we should be able to convert this. So let's look at our X value. X should be equal to R, which is 4, times the cosine of our theta, which is 2 pi over 3. Now, if you don't remember what cosine of 2 pi over 3 is, hopefully you have a unit circle handy, which we do. Our unit circle to the right shows us that 2 pi over 3 lands here, and our cosine value is -1/2. So we're going to take that value, X is equal to 4, times, and this is going to be converted to -1/2. And now X is equal to -1/2 times 4, which is -2. So we have our X part of our coordinate, -2. We now need to solve for Y. So I'm going to do this in blue. Y is equal to 4, because we have them, times the sine of 2 pi over 3. And just like before, we look at this value, we see that 2 pi over 3, the Y value there is root 3 over 2. So we're going to say Y is equal to 4 times root 3 over 2. This could be simplified because 2 goes into 4 twice, and we could have Y is equal to 2 root 3. So our value here, our rectangular coordinate, we should read Y is equal to, -2, 2 root 3. So this is our rectangular coordinate. All right, so just like how the radians would be, like I mentioned, if this is 4, 2/3 pi, it ends up in quadrant 2. The same thing happens here. negative 2 comma 2 root 3, negative 2, 2 root 3 is a little bit up here. It's going to be more than that, but hopefully you get the idea. It is also going to be in quadrant 2. So that should transition over. Okay? Now, if we convert from to polar from rectangular, so that means we're given a rectangular, then we should be able to use its own set of equations. And if you notice, this is actually the Pythagorean theorem, which theoretically makes sense because if we think about a unit circle, the unit circle is created by a whole bunch of right triangles. Now, all you have to do is take your x and your y value and kind of substitute them in. So let's do that. R squared will be equal to, in this particular case, 2. This is going to be our x. This is our y. Our 2 squared plus negative 2 squared. Okay? And remember, this is, sorry, I should put this here. Our polar coordinates is always r, comma, theta. So, r squared is now equal to 4 plus 4, because negative 2 times negative 2 is 4, which becomes 8, which we should reduce. And we should also have a plus minus here because we're square rooting. And it's also possible to have an r that is negative. As you recall, if I had, like, let's say negative 2 comma pi, we would graph 2 and then pi and then jump back across. So you could have negative r's, and that's why we're going to keep this as part of our answer. And breaking this down, we get root 4, root 2, which becomes 2 root 2, and we have our r values. Our r could be either be positive 2 root 2 or negative 2 root 2. Now, keep both of these answers in mind because we will have to consider two different answers. Okay? So we'll have two answers. Technically, we'll have infinite answers, but we'll have two good answers. So, 2 root 2 and negative 2 root 2 are our potential r values. Okay? So I'm going to put that here. I'm going to start one that's 2 root 2, and I'm going to put or. I'm going to put negative 2 root 2. I should have just done it here. That's fine. So this is our coordinate. We're starting to build the coordinate. So solving for theta. We're going to do that in blue. We're going to use a tangent equation this time. So we need to solve for the theta. So tangent of theta is equal to, in this case, negative 2, because that's our y, 2, which is our x. Well, tangent of theta will then be equal to negative 1. And from here, this becomes kind of like our trig equations, right? Where is tangent equal to negative 1? And we're really going to need to know our tangents. Well, tangent of negative 1 is where we have negative positive, because it's a negative number. So this should be negative positive, or a positive negative. And if you recall, since it is 1, negative 1, that means the numerator and denominator are the same as each other. So that should hopefully recall and land us on either 3 pi over 4, because those values are the same, the x and y's, or 7 pi over 4. Okay? And those would be our two thetas. Theta would be equal to 3 pi over 4 or 7 pi over 4. Now, keep in mind that this coordinate is in quadrant 4. So this is going to be kind of like a star. I'm going to put this in purple. This is in quadrant 4. That means in polars, our answer should be here in quadrant 4 as well. Okay? And if you're really looking into this, quadrant 4 should actually be this unit, 7 pi over 4. So when we're pairing this off, the positive 2 root 2 is our radius. So that means our 2 root 2 should be like somewhere here. And then we should wrap around until we get to quadrant 4 right here, which would be 7 pi over 4. So this answer should be 7 pi over 4. And then if we consider this answer, I remember I said we would have two answers. This answer should be paired off with the negative 2 root 2. And I'll explain that I'll explain that. If you consider graphing this particular solution, okay, that means we would have to consider, let's do this in pink, we would consider this as the positive 2 root 2, comma, 3 pi over 4, and then go across. So, keeping in mind, 2 root 2 is 2.82, so that's half, it's part of the way between 2 and 3. So if we consider that, like this is 2.8, 2.8 is about here. If we rotate 3 pi over 4, that means we land about here. And since this is originally negative, right, that means we should jump across. And we are landing in the exact same spot as this original answer. So we need to really, really consider, okay, a polar coordinate could also have a negative radius, but that means we also need to consider its proper theta. So, knowing which quadrant you're working with is very, very important for these problems. Knowing your tangents are also very important for converting to polars. We'll have a lot of practice with this. So if you do have any questions on it, that's okay. Be sure to ask them, and I'll see you in the next one. Bye.